Tony Dubiel here, Technical Solutions Architect working for GES South, focused on data center networking and cloud. Today I'm going to provide you with a very brief demonstration of leveraging UCS Director as an automation tool set. However, instead of using the GUI, today we're going to code the UCS Director leveraging the APIs. So this demonstration is more from a developer's viewpoint than it would be from an operational standpoint from an infrastructure team. Now, keep in mind, the developer most likely does not have skill sets in order to build firewalls, to configure load balancing, to configure network constructs and ACI. So these components and these resources will be brought forth from a workflow based off of templates, out-of-the-box templates that have already been inputted into UCS Director and configured specifically with IP addressing, policies, and specific details pertaining to this lab environment by, per se, let's say an infrastructure person, right? And then the whole point of this demonstration is that a developer could consume those private cloud resources from the API to build them a tenant in a project construct based off of an application profile that would allow for a firewall in a three-tiered app, web, app, and database, along with a second application profile that would deliver load balancing as a service. And then lastly, in the second scenario, we will build an application profile based off of a combination of virtual machines and bare metal. So you'll see UCS Manager would be a component of the automation workflow as well. And finally, you notice that I depict both Postman and Chef on the PowerPoint. And the reason for that is we will start with Postman, which is a great tool to understand which REST API calls that we need to stitch together to orchestrate whatever we're trying to build. And then from Postman, we can convert the REST API code and syntax to Chef. Chef has a REST API client, and if we use the proper HTML and Ruby component of that, we can convert the code. And then that would give our developer their option to use their tool of choice, whether it be Chef, Ansible, Salt, Puppet, etc.
Notice we have a clean slate here for the APIC, and now we're looking at the UCS Director GUI just to give you some background information on how we were able to configure everything to work with the APIs. Now let's take a look at the construct of a catalog. In UCS Director, you can publish a catalog, which is a collection of workflows and templates, and it requires the user to input data into either forms or drop-down menus or table list. So that may be okay for some people, but a lot of folks, they would like to skip a total curated experience and take advantage of the APIs. Now, we're able to customize these workflows, these out of the box workflows, and create our own templates. And by doing so, we're able to stitch together a workflow and make it available to an end user. However, it doesn't have to be limited to the GUI. It also could be consumed from the API, and that's what we're going to focus on today. So here's a template, and I'm going to walk you through an existing template that we're using for firewall and load balancing. And if we wanted to, we could modify the template. So again, we can do that from here, and we can change some of the input in the workflow. This is the existing workflow, as it were. However, if we wanted to, we could actually modify these workflows and create templates and modify templates from the API as well. That would be more of an expert level type of demonstration that perhaps we'll revisit that at a later date. Again, today we're focusing more on the developer experience and how they would consume these resources that have been made available in UCS Director in terms of consumption. Now, how did I do this? Well, first of all, I needed to understand the REST API calls to use as an alternative to the GUI. So in order to do that, I use this tool, which allows me from a REST API browser to discover the actual API call and to understand the input that would be needed, and to make sure that I have the proper syntax to make that API call. So this essentially, in effect, is a testing component which I can run locally from the UCS director. And if I am able to run a particular call without an error, then I can copy that particular URL, that REST API call, and paste it into the Postman tool that I'm going to be using to stitch together my configuration of code and workflow for the APIs. And before we can do that, however, even though I'm able to paste in that API call, we need our credentials. So what you'll find is that I'm going to run into a problem here in a second. But we'll go ahead and allow this to happen so you can see the effect of using Postman API calls. It does require a token to authenticate to the UCS director. So from that, we'll go ahead and look at that process. How can we determine what our credentials are? So first of all, we'll run this particular API REST call, this GET, to determine our token by including our username and password. So at a minimum, we would have to know our username and password to UCS director for our account, and then we can pull in that token. Moving forward, for every one of the API calls that we would invoke, we would continue to use this token as a key value pair to communicate with the UCS director. So that's what we're going to do now. And just to show you that it works, we're going to use that key, and it's just going to validate that that is the key that we're supposed to be using for our user account and password. So we'll go ahead and launch this. I'm just going to paste it in again just to make sure that the key hasn't changed. It should be the same, but just in case. And we can see that that is validated as the key that we're using for the admin account. And this would be the same process for any other user in UCS Director. We would need their specific key to be able to invoke these particular API calls leveraging Postman. Okay? All right, so now what we're going to do is we're going to take a look at the catalog. We looked at it from a graphical perspective. This is what we are able to glean from the API in terms of the catalog. We're going to take a look at tenant onboarding as our first example. Subsequently, we'll also look at some additional catalogs, two in particular. One of which is a combination of combining the firewall and the load balancing templates together to give us an idea of two application profiles, one leveraging firewall, one leveraging a load balancer, and how you can stitch the two together from a task and workflow perspective. And lastly, we'll take a look at building a bare metal and virtual machine tier as well. So before we begin, we need to understand the input. So we need the input of tenant onboarding, and we'll start as our first example. So another component of this is the code. If we were to use or leverage another tool set, in this case, Chef, we would be able to convert our Postman syntax for the REST API to a format in Ruby that we could use for the REST client of a Chef. So that's what we're doing today. That's as far as we're going on the Chef side of things, but you can easily go through each one of these REST API calls and convert them to a format or a syntax that Chef would be able to understand. Now we're taking a look at each one of the inputs. Inputs are either text or they could be a combination of either a drop-down menu or a table. So as we parse through our list of inputs, we can determine, what type of input, such as a pop-up table as an example, and what is required for the input. So this is the required input in order to invoke this workflow, which would kick off each one of the individual tasks. So now what we're going to do is we're going to create input to combine with our parameters that we need to run as part of this API call. This is a post, so this means that we're actually configuring on the system. So get is receiving information, post is configuration. And what we're going to do is create demo video, which is a tenant in the APIC. This is a very simple workflow that creates a tenant. This is just showing us that this tenant does not exist in our vCenter, nor does this tenant exist yet in our ACI APIC. So from this standpoint, we can see that we just have the three, these are the three tenants that are already pre-configured in every APIC, the required tenants. Okay, so we've kicked that off, and now we have a service catalog request ID, and this is how we're able to track the status of this orchestration workflow from the API. Right, so as you can see, we're in progress, and this will take a few moments. Hey, look, it's done. All right. And more importantly, it's been successfully added to our tenants in the ACI APIC, as well as a new tenant that has been added as part of the vCenter environment as well. A cool feature of Postman and UCS Director APIs is that you can take that service request ID, and if you want to, you can roll back that entire workflow and task. So a great feature to be able to build and then clean up. So we'll go ahead and do that. We'll roll back that tenant we just created, and then we'll build it again. Go ahead and take a look at the status of our request. We did it a little bit too quick there. Got to change it to the right number, actually. That was an old API call. So we need 34 to look at the status of our rollback, which is still in progress. Okay, it's complete now. So let's check the status and make sure that it has been cleaned up. So we'll take a look in vCenter, and it has been removed. And now let's look at the APIC. And it's gone from the APIC as well. Having removed the tenant, now let's go ahead and add the tenant back so that we can build upon the tenant in ACI and on top of our vCenter. So we'll go ahead and invoke this service request, which is 35. It's in progress, and we'll need to check on this one here and make sure that it completes successfully. Okay, good to go. Now let's move on to the next catalog. So we'll go ahead and get catalogs, and we're going to take a look at the combination of building the ASA APGs and also the load balancing application profiles, rather. So taking a look at the input first. This is the input that we need to kick off a workflow, and this is actually a good example of a nested workflow because there's several tasks within a workflow, and this is going to kick off several orchestrated workflows underneath the main input. So once we understand the input options and kick off the workflow, much of the other parameters and input has been hard-coded for us. So this would be an example of where the UCS director, the networking, load balancing, and firewall team would have already added input into templates, into IP addressing, firewall rule sets, those types of things, and we're only invoking a template in that example that was provided for us for our use case, right? So from a developer perspective, we just want the capacity and the resources of load balancer, firewall, VMs, etc. So this is our input to invoke the overall workflows. So we're doing it for demo video. $39 is our service ID. However, you will notice that as the workflows initiate, they will create additional service request IDs. So 39 is kind of the foundation, which is in progress. And then over time, as it executes step by step and the orchestration process unfolds each workflow and each task, additional IDs will be created that we can track the status of each one of the embedded workflows. And we'll revisit this because there'll actually be even more service IDs shortly. So far, so good. vCenter is spawning virtual machines, which are virtual appliances of our firewall and load balancer. So we'll go back into Postman and continue to look at the status of where we are with the service request. Now we're up to 75 actually, so we'll go back down to 39, which is the parent workflow. And then everything subsequent to that has been spawned as an embedded workflow. And we have completed our main workflow, and then we'll just check through and make sure that we have completed without any failures all of the sub workflows. And for good measure, we'll go ahead and examine one just to take a drill down into a sub workflow with the specific tasking. So we'll look at this one, 72, that had created some layer 4 through 7 services for the APIC. In order to look at it specifically, we have to put its specific ID, which is 72. Now we are focusing on the details of that particular workflow, where it's a bit more of a drill down. Now, what if we had a failure? If we had a failure, we could actually pull in log information and understand the specific task that failed, and we would be able to parse through those errors. Okay, so now that we've completed, let's go ahead and check the virtual machines from the API without needing to go and leverage vCenter. So we can actually receive fairly decent endpoint data on the name of the virtual machine, its ID, IP addressing, the image that was used, and we can parse through that information directly from the API, which would be considered probably very valuable in terms of a developer having direct access to that from their tool set, whether it be Postman or Chef or Ansible or any other tooling they were using to invoke the REST API calls. We can see that in vCenter we have several virtual machines running in demo video tenant. We'll take a look at the firewall. And just to give you an example of how this works, UCS Director within that workflow had a template that built the virtual machine from an image, but also configured the ASA firewall. So if we look at the running config, we can actually see that IP address information has already been included as part of the internal and external interfaces, and firewall rule sets have been added to this firewall. Along those same lines, we could check out the load balancer as well. It's up and running. So from vCenter, obviously we need that tool in order to bring up a console to check the details of the actual workloads themselves. You'll notice that there's several virtual machines that represent a 3-tiered application: app, web, and database. And the reason why there's 2 of those so far is because we've built an application profile in EPGs for a firewall, and then we built a separate stack for load balancing. And we'll be able to drill down into that in more detail when we take a look at the APIC. So here is the Citrix VPX firewall load balancer. So moving forward, let's go ahead and take a look at the APIC and go into our demo video tenant and build that out. At this point, we've built quite a bit of constructs from an ACI viewpoint. So we look at the application profiles. First, we'll look at load balance app profile, and we can see that we have virtual endpoints, VMs, that are connected into these EPGs and contracts at the top that allow them to have connectivity between endpoints, and also a layer 3 out for external connectivity. And we'll take a look at the additional EPGs that we're going to build afterwards that would actually incorporate virtual endpoints and bare metal, but we haven't got to that point yet. So far, we've built firewall and load balancing for layer 4 through 7 services that are stitched together to two separate application profiles and endpoints. And I'll walk through this again afterwards when we build the second workflow, and we'll look at some of the differences between the virtualized endpoints and bare metal and how we're able to do that. So this is just showing you different drop downs that are specific to layer 4 through 7 devices that we've configured, right, and the interfaces that are assigned to them. So we have multiple interfaces on the load balancer that connect to web, database, app, and then we have our external connections as well. Now let's look at the virtual machines that we've created. In addition to vCenter, we can also view the virtual machines from the API, as I demonstrated, as well as from APIC. You can go ahead and drop down and take a look at, from the VMM, you can take a look at the vCenter environment in each specific host and the virtual machines that we've created from a result of running the APIs. Okay, so we're going to go ahead and we're going to grab some inputs for a application stack that is a tiered application using both VMware and UCS for bare metal. So once again, we must understand the inputs. So we do that from an API call in Postman. And then we're going to create the actual post where we incorporate the input of the key value pairs that we will invoke, again for demo video. And these are the required keys based on input that has been put together in this workflow. So this is a separate workflow from the previous, and this is the required input that's needed. Again, we could add or change the input from the API as more of an advanced exercise, and we're using the workflows that were pre-created for us. So after running it, we have 81 as our service ID, and we can go ahead and check the status there. Still in progress, and we'll come back. Now that's completed, let's pop on over to the APIC, and we can see that we have 3 application profiles now. So we'll go ahead and walk through them quickly. We looked at this earlier, but just to point out and reiterate, these are virtual endpoints. Right, so this is the load balancer application profile. We also have the demo video application profile, which was the first one that that hooked together to the ASA firewall with a 3-tiered app. And then demo video will allow us to take a look at the previous workflow, which included virtual endpoints and a bare metal endpoint from a UCS.
Thank you so much for watching this video of using UCS Director as an automation gateway or an API gateway that that lends itself well to developers using code and their tool set of choice. I hope you enjoyed this video, and I'll see you on the next one.